Hi, it's a guy, Olumide, and today we are going to be solving another one of the most commonly asked tech interview questions by top tech companies including Google, Amazon, Netflix, Microsoft, Meta, Apple, and other top tech companies. Today we'll be considering the next largest number to the right. The problem statement states that given an integer array nums, return an output array res where for each value nums of I. Res of I is the first number to the right that is larger than nums of I. If no larger number exists to the right of nums of I, sets res of I to -1. Okay, what I'm trying to say in that problem statement is that fine, we'll be given an input array nums, and if we look at this array, it is represented in this line diagram that is here. So because we can say that the first element in the array nums, which is 5, corresponds to this line 5 with the height of 5. The second is line 2 with the height of 2, third is line 4, and that's how it goes. Now if we try to find the first number, just like in this problem statement over here, the first number to the right that is larger than nums of I, which is, let's choose I to be 1 I to be 0 now, that is the first index. So the first number to the right that is larger than this 5 is 6. We see that, in the line diagram now, the first number that is larger than 5 is 6. So what this problem is actually asking us to find is a corresponding array that is of the same length as nums. But now this array is going to be representing and is going to be consisting of for each nums of I. It means that for each value, for each element in nums, there will be a corresponding element in res that will be the first number to the right that is larger than that particular number, that particular element. Look at 5 now. In this diagram, we see this 5, and the first number to the right that is larger than 5 is 6. So rest of I is going to contain 6. Is going to contain 6 at that same position for 5, that is in the nums. So similarly, if you look at the second element in nums, it is 2. Now if we come look at the line diagram here, the first number to the right that is greater than 2 is actually 4. So the rest is going to consist of 4. I mean, this rest output, this is the output array, is going to consist of 4. So if we move on again to 4, which is the next element in our nums, we see that the first element to the right that is greater than 4 is 6. So we're going to populate 6 at the place of 4, in this rest array, and that's how we go on and on. So the problem statement says that if no larger number exists, look at this 6 now, there's no larger number to the right that is larger than 6. So we're gonna set it to -1. So we're gonna set it to -1 just like here. And similarly, the last element in the array nums, so which is 1, also have no element to the right because it's the last element, so we set it also to 1. So we're just trying to return an array res such that for each value nums of I, res of I is the first number to the right that is larger than nums of I. A brute force solution to solve this problem is actually iterating through each element in the array nums, and for each of these elements, linearly searching each number to the right, so to find the number that is larger than the current element. So we understand, like, fine, we are going to be iterating through the element of the array 5 now. Let's say we are at index 0, which is 5. So for this index 0, we are going to iterate through the rest of the array to find for a number that is greater than 5, for the next number that is larger than 5. So we're going to do that for 5, we're going to do that for 2 also. We're going to iterate through the rest of the array to search for the next number that is larger than 2. We're going to do this for 4 by searching through the rest of the array for the next number that is greater than 4, and we can do that on and on until we get to the last index. But this actually is going to take us a O(n) square time. So because we have to loop, we have to perform a multiple loop. 2 for loops will be used, first to iterate through each element, and then the second to iterate through the rest for each of these elements. I think we can think of something better and a more efficient way to solve this problem. Now let's approach this problem from a different perspective. Instead of finding the next largest number for each value, what if we check whether the value itself is the next largest number for any value to its left? For example, we can figure out which value in this example, in this particular visualization now, we can figure out which set of value have 6 as their next largest number, and they are 5. We see that 5 has 6 as its next largest number, 2 does not have 6 as its next largest number, it actually has 4 as its next largest number, but 4 itself also has 6 as its next largest number. So 5 and 6 have 6, and 5 and 4 have 6 as their next largest number. With this shift in perspective now and approach, we should search the array from the right to the left. So we should search the array from the right, mean that from 1, just from 1 toward the left, so that we can look for certain values to the left that have the current value at the right as their next largest number. So let's call these values candidates. This value at the right, as we search from the right to the left now. So this value that could have some other value at the left as their that could have some other value at the next, to have them as their next largest number, meaning that, okay, let's take 6 for example, searching from the left to the right now. Let's say we take 1 and we take 6. So getting to 6 now, we know that 5 and 4, well, we don't know, but 5 and 4 are the possible are gonna be having this value 6 as their next largest number. So, and now how do we determine which number qualifies as a candidate? That is, how do you determine that this particular number at the right actually we have will be the next largest number of some numbers to the left, or of some values to the left? Now we're gonna work on that. Let's consider this example. So we're gonna be starting from the right. Look at this example now. This is just a normal string, a number array. So 1 2 1 1 2 3 2 3 2 4. So we just place the visualization like this. So considering this example now, we're gonna be starting from the right to the left, like we concluded the other time. And now the first element we have is 4 right here, which is the first element that we initially know about, because we are starting from the left, from the right to the left. So the first element we encounter is 4. So right now we can say that this first element, which is 4, this value is a candidate. So because it might have some value to the left, toward the left, that it will be the next largest number of those values. So it is a candidate. It has a probability of being the next largest number of some value to its left. And similarly, because this is the very first element we are encountering, we are gonna be setting its results to -1, because it does not it particularly does not have a next largest number. Why? Because it's actually the last number. So we're gonna be setting its result to -1. Don't forget, in the problem statement we are told that if it does not have the next largest number, then we should set it to -1. So we set it to -1 and we added it to the candidate list. So, and what we do now is that we move from the last element in the right to one step toward the left. So we get to this new value 2. Now at 2 now, the next largest number of 2 is the most recently added number or added value that is larger than 2, so which is 4, because 4 is the most recently added value in the list. It's actually the only value in the list, and it is larger than 2. So we are gonna put it here in results as 4, and we are gonna add 2 also to the candidate list. Why? Because 2 could be a potential next largest number to some value to the left. Imagine 1. At least 2 is greater than 1. So if 1 is to the left, 2 probably is going to be the next largest number to 1. So that's why we're adding to the candidate list. So what we do again is that we shift one step again to the left, and we are right here at 3. Notice that with the introduction of 3 now, since we are now on the line 3, on the element 3, the number 2 or value 2 should no longer be considered as a candidate in the array, because this line 3 or this in a value 3 is toward the left in the array. It's even leftmost than the 2. Don't forget, it comes after the 2, so it's toward the left, and it also has a value. It is larger than 2. So therefore, if we should come across any number toward the left now after 3, it's always going to be 3 is always going to be the next largest number of such number. Why? Because next largest number is actually referring to the most recently added number. So it's not really talking about a number that is farther to the end, but it's just talking about the most recently added number that is greater than that particular number. That's the next largest number to the right. So that's why we put the next there, the next largest. So we say that 3 being greater than 2 now, or being larger than 2, and being toward the left than 2, means that 2 should not even be kept in the as a candidate. So because if we encounter a 1 or a 2, it's toward the left now, it's always gonna be 3 is always gonna be its next largest number. Why? Because 3 is toward the left and it's greater than 2. It's greater than all those numbers. So we're gonna be removing 2 from the candidate list, as well as any other number that is lesser than or equal to 3. So why? Because even if here we have 3, the fact that this particular 3 is toward the left than this 3 here, is gonna be the next largest number, and this is not gonna be the next largest number of any other number to the left. So and so that's why we say that if it is either 3 or if it is less than 3. So and because of that, we are gonna be removing 2 from the candidate list here. And because 4 is actually not is not less than or equals to 3, it is greater than 3. So we are gonna retain 4, and 4 will be the new largest, will be the new next largest number for 3 in this results list now. So why? Because 4 is actually the next largest number, as you can see here. So we're gonna add 4 here, and we are also gonna input 3 into the candidate list. Why? Because it has the potential of being the next largest number to other subsequent numbers or values to the left. So making 4 the next largest number in the results for the 3, and then adding 3 to the candidate list, we're gonna move on to the next element in the array toward the left. So one thing I want you to notice now is that this way, by doing this, we have a crucial insight. Whenever we move to a new number by moving toward the left, all candidates that are less than or equal to this number should be removed from the candidate. And this means that, okay, if look at this for instance now. So we have 4 right here, right? And then we have 2 before, but with the introduction of 3, we remove every element that is less than or equals to 3, which causes us to remove 2, and now we have 3. This way we can observe that we always have a descending order in our candidate list. Why? Because whenever a new candidate is entering, it makes sure that every candidate that is equal or less than it will be removed, therefore ensuring that only candidates that are greater than it. Look at this situation now, whereby 3 comes in, but now 4 does not goes out, although 2 went out. So it ensures that it is decreasing, and that's why once we keep moving toward the left, we will keep seeing that it is decreasing. Why? Because whenever a new number wants to enter, it ensures that every number that is less than it in the list is removed. So therefore, only number that remain in the list are those that are greater than it. So before 3 could enter, it ensures that every number like 2 or 1 or any number less than it or even 3 is removed from the list, therefore only remaining 4. Now when we added 3 to the candidate list, whenever I want to add a 2 to the candidate list again, it's going to ensure that every number that is less than or equals to 2 is removed, thereby retaining 3. So that way now it's gonna ensure that the array is descending. So it's descending and strictly descending in nature. Now if we move our index, when we move toward the next index to the left, now we come across 2. Now coming across 2, we are gonna remove every candidate that is less than or equals to 2. Don't forget that so far we have 4 and 3. So now that means that you are not actually removing any element, because all candidates are actually greater than 2. So we're gonna add 2, and now the list, this 3 that is here will be the one that will be under the index 2, which means that the next largest number to 2, so in the array so far, is 3. So and that's why 2 will be added here. So when we move on again to the next element in the array by moving toward the left by 1, we fall on this value 3. So what we do again is that we try to filter out every number that is less than or equals to 3 in the array, which includes 2, right, and 3. Imagine, so we filter out 2 and 3, and then after filtering it out, the next largest number is gonna be 4, right? So 4 is gonna be placed for in to represent 3 in the results array. So and after that, we are gonna add 3 again to the candidate list. So we are gonna navigate again to the next element, to the right, to the left, and we fall on 2. So falling on 2 now, don't forget that so far we have 4 and 3, because the initial 3 are filtered out the 2 that was there before. So now that we come across 2 again, 2 is gonna look into the array to check for any number that is less than or equals to 2, and because there's no number less than or equals to 2, we only have 4 and 3. Is just gonna pick 3, which is the next largest number, and it's gonna be here, right? So and then it's gonna we're gonna add 4, 3 and 2 to the array. So moving on to 1 again, 1 is gonna look for any number that is less than or equals to 1. It's not gonna find any, and 2 is the next largest number, so it's gonna add 2, and it's gonna move again to this last element in the array, which is 1. I mean the first element, but moving left, we say the last element in the array, so and which is 1. So it's gonna check for 1, but there's a 1 there, right? Because this last one that we added is already there. We're gonna add it as a candidate. So and what we're gonna do is that we're gonna remove that one from the stack. We're gonna remove it from the candidate list. Why? Because it is equal to this one. So and because of that, any number that is toward the left now, we rather go for this as its next largest number than go for this, because this one is toward the left now. So and because of that, we're gonna remove the 1, then we're gonna take the next largest number so far, which is 2. We're gonna put it to represent it here, and we're gonna add 1 again. So that's how we come across 4, 3, 2, 1, and you can see now that really they are in descending order. So and this way, this observation actually make us understand that we can use a stack to represent this now. So since stack can be effectively and efficiently used to manage decreasing values, because one thing we can observe here is that, fine, let's say we have 4. To add 3, we are quite sure that by adding 3, we are quite sure that everything to the left is actually greater than 3, and everything to the left that's less than or equals to 3 have been removed and wiped off. So we only have to focus on the top of the stack. Whenever I want to add 2 now, we just need to ensure that 2 is greater than 2 is actually less than what is at the top of the stack. So because once 2 becomes greater than what is on top of the stack, we are gonna pop it off the stack again. So that way now it can help us to manage the decreasing order of values in the stack. and at the same time the top of the stack is going to help us represent the most recent candidate. At the same time, the most recent candidate to the right of each new number encountered. So whenever I want to pick the next largest number, we just go and pick it from the top of the stack, because the top is going to always represent the most recent candidates encountered, and it's always going to be we are always going to be assured that there is no number that is less than that particular number. We are going to remove every number in the stack that is less than or equals to that particular number, so it can maintain that decreasing order. So, and therefore, using stack, we just have to follow this tree process now. First of all, we pop off all candidates. Whenever we come across a new candidate, by moving from right to left, we're going to pop off all candidates from the top of the stack that is less than or equals to the current value, right? So we're going to pop off every candidate from the top of the stack. What this means is that we are going to be while the element, or while the value at the top of the stack is less than or equals to the current value that we keep popping them up until there is no more value that is less than or equals to the current value. And after that, now the top of the stack will then represent the next largest number of the current value. At that point whereby there is no more value that is less than or equals to the current value, definitely the value at the top of the stack is going to represent a value that is greater than, and at the same time will be the next largest number of the current value. So, and what we're going to do is that we're going to record the top of the stack as the answer for the current value. So meaning that in this particular result array, it will represent it will be represented by the value at the top of the stack that is actually greater than the current value. So, but if the stack is empty now, that means there is no next largest value, largest number for the current value. So it is the largest so far, and we're gonna record it as -1. So what we're now gonna do is that we're gonna add this current value itself as a new candidate by pushing it to the top of the stack. So, and that's how we're gonna be solving this problem now. So we'll be going to the code implementation now. Alright, let's move into the code implementation. We'll be defining this function as next largest number to the right, and we'll be collecting the nums, which is a list of integer, the array, and so I will be returning another list of integers, so which will be the results that will represent the the next largest number to the right for each index in nums. So let's define the array as the result array as let's populate it as an array of 0, so times len of nums, right? So we are defining it now. So, and then we'll be having our stack as an empty array as well. So what we want to do is that we want to iterate through the nums array from right to the left. So, and that will give us for I in range of len of nums -1, comma -1, comma -1. So here we are trying to iterate from the right to the left. So len of nums actually represents the last index in the array, while this first -1. So this first -1 here actually represents the destination, is like the start, the end, and the space. So this -1 here actually means reverse, that is reverse it and move one step at a time. So now for this, what we want to first of all do is that we want to check if the stack, if the element we're trying to put into the stack, don't forget we're starting from the end now. So before we put in an element into the stack, we need to remove every other element of value or candidates that are less than or equals to that value. So while stack, that is while the stack is present, and then stack of -1. So while it is less than or equals to nums of I. So we need to remove every element that are less than or equals to the value that I want to put in. So every value that are in the stack that are candidates already in the stack, right? But they are less than or equals to the candidate want to put in now. We got to pop them now from the stack. So that's why we are trying to refer to the very last element in the stack as stack of -1. So and once we can remove all of them now, so we can now update our results. So we know that the very last one that will be in the stack will be one that is greater than the value we are trying to put in. So why? Because we have performed a loop now that we keep on removing every value and every candidate from the stack until it gets to one that that does not really that is not less than or equals to the candidate we're trying to put in. So result equals to stack of -1, that is the last element that is not less than or equals to nums of I, that is greater than nums of I. So if stack, so you know there's some situation whereby every element is actually less than or equals to nums of I. So every element is gonna be removed, is gonna be popped out, and in such a situation we are gonna represent it as -1 instead. So sorry, res of I. So the corresponding I is what we are trying to change. And after doing this now, we want to append into our stack that append nums of I. So this way now we are sure that nums there's no number in the stack that is less than, or there's no candidate in the stack that is less than or equals to nums of I. So that is the current candidate that we are at, and after that we can now return res. So it might look a little bit cunning, but what I'm trying to say is that first of all, I created the results array, so to be the same length as the nums. That's why I populated it as 0. So I initiated it as zeros array. So and then we define our stack, and then we iterate through in the reverse order like we explained in the logic. And what we want to do is that we are trying to add that particular each of the value, you know, right from the right to the left. We want to add it to the stack. But before we do that, we want to remove and pop out every number or every candidate in the stack that is actually less than or equals to the current number that we want to add in. So why? Because if we are trying to add in a number now, the number means that is the most recently accessed number, the most recent number. So if there should be any number to its right, I mean any number that is already in the stack that is less than it, definitely is of no use. If we go back to the logic, you will understand what I'm trying to say. So because the first thing is that this particular number is greater than or equals to that number. This particular current number is greater than or equals to it, and it is even to the left. So every number that follows it has a high probability of reaching it before that one that is after it. So that's why we are trying to pop out every number that is less than or equals to the current number, and after doing that, we take the next number that is larger than this current number, that is the one that is not removed. We are gonna take it and then set it there. But if there is no number, we're gonna set it as -1. And then what we wanna do is I want to append the current number into the stack. And after doing that for all the elements in the array, we're gonna return res. So let's populate our parameters now. So we'll be needing the nums. So fine, we have our nums and our parameters. So I call the function now. Let's run it and see. So we expect it to return another new array res that will represent the next number for each element. And right here we can see it printed as minus 6 4 6 minus 1 minus 1, which is actually correct. And that's it. That's how we solve this problem now. So alright, do well to like, to follow, and to share, and to subscribe to our channel on YouTube. Thank you for watching, and I hope you understand this.